This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg, I'm your host, and I'm going to be talking today to Vlad Larichev. He's the Industrial GenAI Lead, Data and AI for the DACH region with Accenture IX. And Vlad and I are going to be talking about and I guess around the topic of GenAI in engineering. Hi, Vlad.
Good morning, Peter.
How are you doing?
Doing great. So you described a lot of exciting topics where I think everyone's attention currently is very focused on. So looking forward to our discussion.
Very good. Why don't we start with you introducing yourself to our listeners, please?
Sure. So as you mentioned, my name is Vlad. I'm based in Aachen in the near of Cologne. From my background, I'm software engineer. Actually started in engineering, but then later noticed that I was maybe a bit of naive about the velocity, or I would say speed in engineering. So many processes were a bit slower as I expected. So I discovered for me software development and moved being later a full stack software engineer, worked in several positions. And then I had an interesting opportunity to build up a department in a company which did machine translation at that moment. And at that moment, I had not really a focus on AI, but it was exactly a time as transformer models kind of become mature enough. And my task was to implement transformers in the department. And we were building custom transformer models for our clients in retail as B2B model, actually kind of a training small open eyes, I would say, in our basement. And it's absolutely fascinated me. So the nice thing about that the models were so small that you actually could really try to optimize each small component on it and really see how it works on a, I would say, math level. And I was super fascinated by how you can translate things like, I would say, humor or human logic or emotions in simple math operations, vector operations, when you can calculate them, translate it back, and it's humor again, but in another language. And it was fascinating, but the models were super small at that moment. So we were actually just building models, for example, from English to German and German to other languages like Japanese, but you were not able to translate between the languages. And at that moment, everyone was fascinated by the idea that someday you will be able to have, for example, one model for all European languages. And everyone says like, wow, this is like too futuristic and we will never achieve that. It will take years. So I moved to Umlaut since I really missed engineering topics. And Umlaut was an engineering consulting company. And where I was responsible for business development and portfolio management of our custom software and AI products. And later, Umlaut was acquired by Accenture. And since then, as you know, the topic of GenAI skyrocketed. And I, since then, looking at the topic of how we can bring GenAI, but now, of course, also AI and all other architectures around AI into industrial processes in a scalable, secure, and trustworthy way.
Sounds great. Thank you for that introduction. From engineering to software, back to engineering. Let's start with the topic of engineering. So as I just learned, and as the listener learns, you and also myself, we're both at least trained engineers. What is engineering? What does the engineer do? Or maybe you can start with sharing, if you know, there's this famous saying in German about the engineer. Do you know which one I'm referring to?
Which one?
I think, do I dare to pronounce it in German? It says...
Let's try.
No, I can't. Für Ingenieur, nothing is too schwer. Like that. Well,
Yeah.
That was very, very bad. I suddenly have a problem moving backwards, forwards to German and English. And what it means is there is this saying that, the engineer can do anything. Nothing is too difficult. So what is engineering? Engineering is the thing the engineer does. But if we use the term engineering, just tell us what does it really stand for?
It's interesting perspective, Peter, because I think for me it was very interesting to move from engineering to software development to really see that there are a lot of in common. I agree with you that engineering, in my opinion, is also more like way of thinking about the problems and how you can deconstruct something complex in a simple components. And I think that our colleagues in software development have a bit easier life, maybe, since most of their formats and data is compilable. So they have so what we trying to build in engineering, you have a topic of digital thread is something I would say our colleagues in software development have already for longer time, since they are able to compile the code directly and understand, okay, like what are the connections and how you can come from the requirements directly, for example, to the output, and you can verify if the output is correctly in a second. And this is also an area where I believe that all the development in co-pilots and GenAI was quicker in software development as in other areas because of this process. I agree with you that engineering is also, in my opinion, is approach. So you can think as an engineer about many topics, and the challenge we had there are, I would say, in comparison to software development, are very different to challenges in software development. Yeah, it's a variety of formats, a lot of software tools we have used to be able to be performant. So we don't have a one editor, for example, amount of disciplines, and also the isolation of these disciplines. Yeah, so if we look at a larger projects in engineering, the challenge I see is that for complex projects, you have many different disciplines which have to work seamlessly together to verify, to enable on the end a product which combines it seamlessly. And especially now with the topic of software-defined product is getting even more complex. So I would say engineering is a way of thinking, but there's a very different ways as an engineer to think about the problems.
Right. Does an engineer design hardware, software, while the software developer develops software? Is that a major difference between the two?
I would say also in discussion with many of my colleagues to say, like, in 2 weeks we have co-pilots which will write enterprise software. I think it's the same to say, like, in 2 weeks we'll have AI generating planes just because it can generate some particular components of it. I think we are maybe on a way there, but if you really deep dive in especially brownfield environments, the complexity is the point. And we learned so much in software development over years about different patterns, how we can handle this complexity. And this is not obvious if we, I would say, vibe code some small application. We are impressed by first results, but actually to bring it to the level of performance is the challenge. And I would say the similarity between engineering and software development is this approach. You have a large complex problem which is not solvable at once. You have to create small subcomponents, think about them, and design solution which later will result in one product where all these subcomponents are integrated together. So in this way, both disciplines are very similar. It's just different languages.
Good. So we are already kind of in the middle of the future, almost. Well, today, future. I do want to go one step back, and then we'll come together at where we are today and how we see things changing. So I myself studied computer-aided architecture design. So I encountered the first huge structural change from the drawing board. I've been spending nights on the drawing board, and it was only at the second part of my studies, that was the computer-aided design phase, when we started developing software. They were exactly the same topic which we're on, the first computer-aided design software. So is that one that you experience? Have there been, if we look back, whatever, your young life, but when you look back, is that the only structural change that we've had in the past, whatever, 30 years? Or have there been other structural changes until then? We're going to look into what has happened the last couple of years.
I would say there are so many topics which are behind the scenes in different disciplines. And as you mentioned, if you talk with people who are in embedded software development or hardware design and engineering, there are so many disciplines, and each of them, I think, had over the past 10, 15 years different tipping points, which radically shift the way how we work. I remember very similar development in one of the areas where I worked as a student. So I worked in a company which was primarily focused on geoinformational systems, so GIS. And they told me that at their time, as they founded the company, their nicest type of work was drawing maps. So it was a high paid engineering task. And they just had a huge roll of paper, which they threw over floor of the whole office. And there were like 20 engineers sitting with lineals, and it was a hydrology. So they drew all these lines of water levels on different ground levels. And it was a project like for 3-4 weeks, highly paid and very, at that moment, very specialized with a lot of expertise. Now, every student in university who starts this discipline can do it after 2 weeks of study with one click and about 3 to 4 minutes. So at maximum.
Based on satellite and many other different kinds of data, I guess.
Yeah, and this is this convergence, of having better data, having better algorithms, and having also software solutions which provide this functionality and kind of outsource this expertise as a business logic to the user. And I think now we have another layer top on that. So still, this entry to this business logic and to this process was kind of complicated. We had to work for a long time. And here again, I see a lot of convergence now with help of LLMs and these interfaces, which simplify this entry. And I think this will give another wave of acceleration in all professional disciplines.
Let's stay then with the LLMs, GenAI that arrived a couple of years ago, kind of we're at the very, very middle. But again, your story brings me back to, as I just said, and we were writing the software, and many of our colleagues at that time, young people at the university, people who were established engineers, architects, he said, "Oh, that's bullshit. You need to do drawings on the drawing board and with your hand." Let's look at that. Is that the same today, where many other people, many listeners are big fans and try to do all the things that we're going to be talking about, but at the same time, there's always a group of people that says, "Oh no, you cannot do that. You cannot use LLMs or GenAI for engineering."
So your question is if LLMs are already applicable for such a specific task like engineering. And on the other side, we have a lot of processes which are very traditional, right?
Yeah, to put it the other way around. Let's look at what are LLMs changing, GenAI changing today structurally, what has already changed, what is changing, and then we can come back to the question and say who is using it? What is the type of person doing that, and what is the type of people say, "No, I don't like that. I don't want to do that."
Yeah, I would start by describing maybe my point of view of LLMs in general. And I think it's quite specific just because of my background, starting in machine translation. And to be honest, now looking at 99% of the use cases on the market, for me, almost all of them are translations. Just because we started in the beginning with translation from one language to another, then some smart guys figured out that you can translate English to SQL or to Java code. Later, some people noticed we can translate now even between disciplines, or we can translate English to some specific format. And where we're now heading to, and I think this is super exciting in my opinion, is this reference back to our first topic, that the complex projects in engineering involve many disciplines which actually speak different languages. So all of them maybe speak English, but if you're one table with somebody from OT, IT, somebody who's responsible for finances, for legal topics, all of them, speaking about the same terms, have different pictures in their minds. And in large projects, this leads to huge problems, because if a main stakeholder will say, okay, I have my main requirements as the project is simplified. Security, So somebody who is in software development will have absolutely different picture in mind as somebody who is, for example, a skilled project manager or somebody building hardware for this project. And I really see from my background and my experience in these larger projects that this misunderstanding between discipline leads to a lot of problems later. And where I'm super excited about the implementation of LLMs is not only because of the opportunity to generate content. It is in the word generative AI already, but I think, in my opinion, it's just only one of the three exciting capabilities of LLMs. In my opinion, the exciting part about that it can actually translate between these different disciplines. And speaking about things like digital thread or model-based system engineering, yeah, we can really go now to the unified representation, or as a software developer would say, maybe state of a product, and then you can translate it back to different disciplines. And somebody who is, for example, responsible for cybersecurity can translate requirements back or give a better feedback to his colleagues who are responsible for software implementation. And I think we are just scratching on the surface of this development, and we already actually see it and use it in our own projects already on, I would say, the foundational level. And sure, there are several bottlenecks at the moment where I would also say we are not there that we can design new cars or planes maybe next 2 weeks completely solely with LLMs. There's a lot to happen there, and of course topics like context, of course, yeah, deterministic approach there. There are many topics to solve. We can speak about them, but still, just looking back over the last 5 years of a development of transformers and also LSTMs, for example, there are many times where somebody put me a list in the hands and said, see, that's why LLMs will have no future. And I see this list so many times. And most of the times, like 2 months later, 80% of these points were solved. And that gives me a really good feeling about the integration of LLMs in engineering as well.
Okay, so you put translations at the very core. Maybe we can call it conversion as well. And what I hear you say is like that eventually we are conversing our thoughts, right? Our thoughts, or maybe they are still requirements, which is the other word you use. So we have a requirement set, which we get as an engineer. If we do it for ourselves, we have already a thought. So it doesn't matter where it starts. And this thought that we shall design, eventually build a machine, a bridge. It doesn't matter what it is that we're going to be doing. A combination, as I suggested, from hardware and software. And I hear you say that is, in the end, that is today. It's a conversion. Today you can speak to a receiving LLM, and the LLM maybe / agent, we're going to be talking about that, is going to come with a number of proposals for you that look like, oh yeah, something like this is what I wanted to do. Now just, build it for me, kind of thing.
Yeah, we see already this in software development. Yeah, you already can open Claude and activate artifacts. You can just use voice input and say, develop me a calculator or meditation app. And with 80% of success, you will have your POC developed. And here again, the point is, why is this possible? Because it can iterate itself just in one instance. It can compile. It can test different hypotheses and understand how to iterate. At the moment, this is not possible yet, one-to-one in engineering, because we cannot rely just on one interface. We had a bit more complicated architecture, but we can later discuss about how we actually already been able to implement that in our own project.
Let's do that. Let's see what GenAI is in the middle of changing with regards to engineering. What tools, what architecture, whatever approaches, and maybe you want to look at the different sections of the engineering, and then the question is GenAI adding value on each of these phases of engineering?
Yeah, sure. I would start by one concept which explains why I go through these different phases. So I think most of the listeners in your audience are very familiar with the V model, which describes the approach from the architecture design on the top left side. You can imagine this V as a letter, and then we follow this path of a V going into requirement management. On the bottom of this letter, we have a design phase, mechanical design, electric and electronic design, software development. And then on the top, again, when we rise on the top, we have the right side with integration, verification, validation processes. So in a classical engineering approach, these all are mostly different disciplines with different teams working on their particular scope. But there's a major shift at the moment, which we observe. I would say the major shift is this demand of a market on smart connected products. So in the past, if you look back on topics like consumer products, a vacuum cleaner, like 10 years ago, even if I would buy a vacuum cleaner, I would just look at the power, maybe on a color, maybe on a form, and say like, perfect, I will buy it. Now, if people buy a physical product like vacuum cleaner, they expect to have a app to it. It should be autonomous driving through your house. It should be connected to cloud, and it should have even a LiDAR on its top, or even mechanical arm in the latest one, which can put away your socks, for example. So it's actually a small autonomous robot which you buy almost for the same amount of money as before a normal vacuum cleaner, just a mechanical one, would cost. And just to give a perspective, just round about 8 years ago, Elon Musk said that he will never bring a LiDAR to Tesla because it's too expensive and adds too much complexity, which he doesn't need on Tesla. And now we expect to have the same approach in technology on small consumer product for $300. And we see this shift from the value in the product, from mechanical values to intellectual or AI or applied intelligence data-driven properties of a product. What does it mean? That the whole cycle from requirement management to integration and software development is being squeezed in one process. And we see in the cycles that different departments are now just throwing back and against to each other with different changes and comparing, especially to, I would say, some other countries developing product. Many clients of us or many companies in Europe have ambition of becoming faster. Also for our own projects, we also provide engineering services. We also are ambitious of becoming more efficient. Of course, I think most of the people in professional field tried to apply already LLMs for their particular discipline. We did as well. So we have, of course, as I think most of the listener, already a backlog of different ideas, experiments, and solutions for each of his discipline. But I think the exciting part is not to accelerate verification and validation with LLMs, or say I can have a plugin for requirement management, which we already have. So our plugins in CodeBeamer, for example, or Doors can test the quality and just verify it based on the prompts which you provide and give us suggestions. So I think there are many of these examples already in the market, and people who are specialized on these areas know them. What excites me is if it's possible to bring not only the generative capabilities of LLMs, but also the reasoning capabilities, not only in one particular component, but actually across the whole process. So as I call it, digital reasoning thread. So can we bring one reasoning instance across all these components to help us through the whole process? And there we see the actual real shift, I would say, in engineering.
So can we?
Yes, we can. Yeah.
Yeah. I mean, reasoning, this huge topic of reasoning, almost whenever it's being discussed in public, like it becomes very philosophical. There is a group of people who will then, and probably I've, or most of the time in the past, many years ago, been doing something similar along the lines of only a human being, or at least did I say a mammal, I guess, should have been born like a human being, like a mammal, and then been raised by other humans and having experienced, etc., 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 which I probably would have said, written, thought, then to come implicitly towards reasoning. But that is not necessarily, I believe, as we are looking today, what reasoning is. But what is? So you're proposing it. So can you explain then how you see a way, how do you see that work, a reasoning, a software algorithm-based solution?
Yeah, I think the biggest challenge is how we can bring this capability in such a complex domain as engineering. I think most of the listeners already tried to use something like DeepSeek, or we also have now some of these capabilities and tools like OpenAI's ChatGPT. And I think for people who work in engineering, this gap is very obvious. So one question, of course, is I ask LLM to think a bit longer about how to calculate, I don't know, some simple math task, or some simple, like, to reason about some logical task. And I think most of the people will say, okay, like, it's good, but how I can iterate on a mechanical part design? Like, there's a huge jump from the capability of OpenAI to reason about a logical task from a school, and actually LLM being able to modify, to change in the LLM or in some simulation tool a mechanical part, and to understand what's actually a change. And I think we can go in this philosophical direction, like what is reasoning, or what is creativity in this area, or what would be our expertise as well as engineers in the future. But starting by, I would say, more pragmatic approach, the question is, can we bring these capabilities of, I would say, thinking, I will dare to use the word thinking, to this process, is the question, in my opinion, of architecture. So I think we're already far enough. So from what we see, we have already, our tools are good enough for bringing reasoning capabilities in engineering, in, I would say, simple tasks.
I do want to stay a sec with what that reasoning is. There's reasoning, especially, let's say, within the engineering phase. Maybe, we could talk about engineering in whatever, we could talk about reasoning, right? In retail, in medical, in whatever kind of medical, of course, you need to design. But if we close it for the moment around engineering, again, designing, building hardware, software, products, in our case, specifically in the industrial space, does reasoning at least require an implicit understanding of the physical world? So reasoning, I mean, if we do bring it back to this human, and the human has, let's say, on top of it, it doesn't have to even have studied engineering, but knows that we have some kind of law, Newton, that says, we stand on this world, we don't fall upside down or something like that. So that's just so then we move into physical AI. Is that at least a necessity, that the majority, if not all, of the physical laws that are known by feeling, by experience, by humans, that the algorithms need to be able to, let's say, have them, know them, understand them?
Yeah, I think not for majority of the tasks in engineering. So I agree with you, and it's a super exciting journey over the last years. Yeah, I think there were two different camps in the area of transformers. Well, one group of people, I would call them group of stochastical parrots, over the last 2.5 years, were saying that LLMs are just kind of repeating and gluing together patterns and tokens they learned before, and there is no actual understanding of a correlation, of real world correlation behind that. There's another camp on the other side from the beginning, which said that there are some examples or some proofs that with high amount of compute and learning we bring into these models, this model not only repeat the patterns, but actually learn so-called world model. Even from simple things like text, it can try to understand how the correlation in the real world might be. And there's very small examples on the internet where you can just take a look, for example, on very small scope, how we can see that, I would say, we're more on the right side. So, for example, if you train a small CNN on recognizing faces, for example, and you will train it far enough, and there's a tools where you can see which nodes are being activated and fired if you put later a new picture. Then you will see that from some particular size of your model, not only your model will recognize that it's face or not face, you will later see that some particular nodes are firing where particular emotions on the face are there. So without actually a training set which explicitly explained what is emotion, with a size, there were a group of nodes which understood that it can, I would say, specialize on a group of attributes which we as a human call emotions or expressions on the face. And this is a very simple example on, of course, what's happening in LLMs on scale. But the problem is that our LLMs, of course, are trained just on text so far. And I have this picture of a human sitting in a dark room with endless amount of time, with endless amount of information, without eyes, without hearing, trying to understand how the world works. And we can imagine that it's super complex to understand the real correlation, and it's already very impressive how good they are. But of course, there's a limitation, especially when we speak about physical processes. But also there are very elegant solutions and developments in this area with physical AI, I would say, one of the major drivers. So we learned with LLMs how the logic, I would say, of most of the processes work on the surface, some correlations about the world model. Now we give this LLMs tools so it can operate the digital world. Yeah, it can operate later, I would say, our tools for FEM simulations, for verification, really applying these tools to our digital world. And with physical AI, we give the opportunity to these reasoning machines to really interact with the physical world and have this back loop to the learning system. And we see this development with NVIDIA. So this is a public topic that we with NVIDIA together and Kion, for example, bring this.
Let me stop you, because if I don't, you're probably going to continue for another 20 minutes
Sure.
on what is great. On what is great. But I will just break in here and just for a moment. I assume, because if not, I'm going to forget the things I want to ask you about what you're telling me. So you were starting with the two groups of people, and I assume that you see yourself not part of the statistical parrots supporters, but more of the second group that believes that there is something more in the models, right? And I must confirm, I'm not sure that I have been there for some specific, but we had a specific breakout session last week when we were with our conference in the Alps with the Stratus Unworld model. So I'm completely with you there. Let's look and do come back to, you were going to talk about NVIDIA. Don't forget it. So bring it in somewhere. If not, I'll remember you. So let's talk about, then you mentioned the architecture. So what is then the architecture of the Gen AI based solutions that we're talking about that is going to be, giving us the capability of moving towards reasoning capabilities?
Yeah. So in my opinion, there's one particular or three particular blockers of bringing these capabilities in real engineering problems. As I mentioned, the first one is that we have to operate real tools. So we cannot just have a ChatGPT 10, which can really simulate physical products. We just need to operate different tools together. And maybe talking about topics like MCP, someday it might access them, but I assume not in a manner we need that, especially since many of the tools runs locally. The second point is the variety of the domains. So as we discussed, we have very different disciplines and very different ways of thinking in engineering. And I think most of the listeners already had the experience. If you have one chat in ChatGPT even, and you put two different topics, you ask about the breakfast, then you had some planning for your travel. Later, you would like to ask to translate some news. We have illusion of a conversation with LLMs, but what's happening in the background, but you have this snowball where your web browser basically sends over and back the whole conversation, and LLM have to parse the whole discussion each time. And for us, it appears as a kind of a conversation, but actually it is a fake. The problem is that if you mix too many topics in one context, the results are getting worse and worse, and you have this rolling barrel effect that you kind of override your context in before. So never it will be possible, in my opinion, to solve topics like engineering in one context. So we have to solve this as well. And the third topic is how we can bring all these disciplines together in not jumping from tool to tool and window to window. So our approach there, how to solve this, It's kind of a mimic department. So we split this logic in two layers. And to follow this analogy, you can imagine we have a manager and we have specialists. So it's very kind of similar to how our companies decided to work over evolution of our, I would say, enterprise.
Don't tell your manager.
Yeah. So we have the goal of this manager, or we call it orchestrator, is actually not to. This manager has no clue about anything actually, so he's not a specialist in. Without making a jokes, his task or his talent is in delegation and splitting complex tasks in subtasks. So this orchestrator is an interface to the client, I would say. So you as a client can give this manager a task, for example, to modify the product, taking into account some particular requirements. So what this orchestrator will do is not directly jumping in and saying, yes, I will help you, and here's your text. It will split your requirement in different tasks, like define the hierarchy or define the relationships and interfaces of this task. And it understands in general, like what are the disciplines which are involved, but not going deeper. And beyond that, we have all these tools which you have to operate. Yeah, so for requirement management, so for verification, validation, 3D modeling, some of these tools already have good APIs, some of them not. And in the middle, we have something new which we designed for ourselves, and we think about many areas of merging it or using or leveraging MCP, but it's self-developed format which we're using already for 1.5 years, which is kind of a AI APIs for these tools. We call them executors. And these executors, they have no clue about the overall goal on the top. So they have no clue actually why they do what they do, but they are specialized on particular task. And what it gives that this executor provides the whole context of a session just to one particular task. This particular task could be, it takes the input, it translates to the format which API expects, it gives the input, it can see also the application, and gives the summarized results back to the orchestrator. So orchestrator don't have to spend the whole context of it, the whole, I would say, attention to the details. And in this way, we can really build a closed loop from requirement to simulation and documentation with this reasoning thread as an orchestrator and with smaller agents which can operate the tools.
There is the word I was going to ask for. I waited for it. Half an hour. Agents.
Yeah.
Because no,
Oh,
I
yeah.
was not, of course, not only just going to ask for it, but already the way that you described this architecture feels to me like could be, doesn't have to be, but could be agents. So and in combination with, now you say there's the department head, the manager, and then the different organizations. So they could all be agents, and at some point in time, and we've seen it communicated before, we could have this one man show companies is so, but that doesn't have to be. But nevertheless, the pieces that we talked about, the elements, are they agents typically? Could they be? Doesn't matter, or are you call them differently?
Yeah, so I see the development of agents very similar to the development of the term AI for the last, I would say, 20 years, or also topics like AGI at the moment. Yeah, so there's a very funny picture of a human sitting on a desk and striking through all the milestones of AI, saying, no, if AI can this is just like a small algorithm, not actually artificial intelligence. And there is a joke that AI is always this. People understand under AI every time all the things which current technology cannot do. So people kind of, I would say, have a feeling, yeah, okay, if it's possible, it's like simple algorithms, but actually I should do something else. And we kind of simplify what's already possible, saying, yeah, like music generation, this is obvious, this is just patterns, or image generation. Yeah, and we a bit oversee, I think, the amazing advancement over the past 2 to 5 years, and similar to agents. So there are many different definitions of what agents are, but for last, like I would say, the common definition is that agents is actually the combination of the LM plus specific knowledge plus specific tool access, and you can decide like which tools it can use. You can decide if there are some actions that trigger or not. But already these three components, like action, tools, and custom knowledge, creates an agent. I remember like 1.5 years, 2 years ago, it was a vision of having a custom LLM which can trigger something. Now, actually, you can argue if a custom GPT is already an agent. So it's in the basic definition, it would hold all these three components. Now, of course, as these agents became so democratized, we again shift the definition of agent of something again futuristic, of having invisible employee which can solve our work and tasks, it can reason on itself. And I think their like definition of mine is something in between. So I would say our architecture is already agentic, and I would say also talking to all our partners and solution providers, I believe this is one of the most advanced multi-agent systems on the market at the moment. And I liked about that it's not only theoretic, we actually use it by ourselves, and it was not a concept, it was a design process, because this is the only one approach how we can solve these three challenges which I mentioned in the beginning.
When you shared the AGI joke, I thought of there is this sign. Not sure you've seen it before. We've got one of those on the fridge in the exercise room where I play the music, and it says "free beer tomorrow."
Yeah, exactly. That's
it always works.
summarized.
Like, it's always like, oh, tomorrow. Okay, I'm going to come back tomorrow. And then tomorrow, the sign is still there. It said, oh, free beer tomorrow. And I believe that's kind of, I know what you were referring to there.
100%.
We always, something that we were completely flabbergasted about a year ago. And we said, I call it the aha, or you were a little bit scared. You look around and there's somebody watching me. What's happening here? That's normal today, and it's going to continue like that tomorrow. Let's talk about maybe a little bit, one step a little bit deeper. Let's talk about data. How do you go about, how shall maybe listeners consider going about making the data in the specific use cases they have available through search, with connectors, what destinations, what can you share with us? What has been your experience there?
Yeah, I would say all discussions starting about agentic architecture, the future of AI, if we're really diving into it in the reality and the praxis, like the next topic is always topic of data, and many things are shifted and changed. I would say comparing to classical AI disciplines. So in most of the discussion and workshops, when people talking about AI, I have to admit, most of the people talk or ask about LLMs because like AI, of course, is a discipline which is there for years. And I think what's shifted is that before, AI was a very niche discipline. So each company had their department for applied intelligence, for AI. They had their wonderful backlog of projects, most of them computer vision projects. What changed now is with this democratization of transformers and LLMs through ChatGPT, everyone tried at home what it could do eventually and tried to apply it somehow to own processes, and got this excitement that actually I could try to build it also in a company, accelerating some manual task. What was the result? That we now facing a huge variety, especially of unstructured data, and also unstructured data, which not particularly was prioritized in all kinds of data catalogs before. Now we see a lot of value in our data sources, what was actually not prioritized before. So it's really a challenge how you bring it, how you evaluate if it's feasible. The main change we currently see that before 80% of the use cases, or even 90, was actually some text input. Yeah, so for maintenance logs, for technical manuals, for all kinds of data. Now we see a rising hunger also of all departments to use image and video, structured data like sensor data, production metrics, or unstructured data, of course, code as well, or even going in the direction of 2D, 3D, or even 4D models like 3D over the time. And this is super challenging. And what I observe is currently a shift from classical data marketplace thinking, where the IT was providing this data infrastructure, bringing all data to one platform. Now more to other sides, like the 2 years ago, each department started to build their vector data banks, and there are many solution providers of that. And we call them knowledge consumers. So the point is that you would not like to have each department to have own solution for these RAG applications. You can save a lot and you can optimize a lot by leveraging joint patterns or joint infrastructure for that. But even this was not enough, because now we go in this cognitive area where we have this all knowledge of processes, and we started all this discussion with knowledge graphs. So how we can bring ontology to this data, relationship between the data. So this makes the whole data topic even more complex as before, because we learned, and I think most of the people in the audience as well, that RAG enough, especially industrial, is not performing well enough. So RAG, retrieval augmented generation, is based on a vector search. You have a similarity search where we have this vector where LLM tries to grab into a huge bucket of the data and just pull out everything it will find, which works very good for topics like, I would say, marketing or history, or topics which are very distinguished. But talking about industrial, where most of the data are ID based, for example, so IDs are super similar, or topic of oil could be about your brake system, your cooling systems. So we have this logical layer you have to bring into the data, otherwise your search will not work. So all these topics coming together, really shifting the architecture of the data. But the major shift I see at the moment is kind of a rethinking the value of the data. So we speak about the data probably, I don't know how many years, but the reality I've seen, especially industrial companies, and this is my personal feeling and belief, so please not quote on that, but from what I've seen is that most of the companies, especially in Europe and in DACH, talk about AI being like new oil or something else, like new gold or super valuable resources, but in a reality, they treat data as a nuclear waste. So they save it, they store it in some salt mines very deep in their basement. They archive it in formats which nobody even can use now, hoping that the future generation, the future tools will somehow kind of make use of it. So it's very, very similar how we treat our nuclear waste in our salt mines. And the problem was that all this data stored there, like companies hope that they use it later for their engineering excellence, because they say like we stored like over 100 years of processes in all this data, but the data was without context. So in many areas, people cannot even start something with this data. And it's super hard to make use of this data, because like 95% of the data in industrial is very repetitive. And only like 2 to 3% of this data are really like these insights which we need. And to distill this data from this amount of data which nobody understands, this is a second challenge I really see at the moment, which all these large industrial companies are facing.
Okay, I'm going to break in a second time, because we don't have 2 hours, we only have 1 hour. Very good. So what was I going to ask? I forgot. Tell us about then, maybe share an example or two. And the question I was going to ask before that, so we still need to provide the metadata, so the relationship, let's say as an example, if it's OPC UA based, the information model, the knowledge graph, so the relationships, the meta information, we today as humans still need to provide in one way or the other, such that the algorithm can do something with it?
Yeah, I think there's a short and long answer to it. The short answer, yes. The long answer, giving you one example. Already 2 years ago, we had one project, which at that time we thought, I think it was 1.5 years ago, as this whole topic of RAG just skyrocketed. And at that moment, everyone thought RAG is a solution for everything. And we had a very large project from one of the largest roller coaster producer. And they wanted to have for their field engineers a manual where you can just go to this roller coaster and make the maintenance without printing out the files and calling the center. So for us at that time, it was a super simple use case. They thought, we put all the maintenance blocks into this application, done. The reality is that this application was not performing at all. It was super bad quality and the client was super unhappy. We opened the data and just went through these logs. And giving you one example, you go in the chapter number 2, talking about the maintenance of some roles there. And the first sentence in the chapter 2, please go back to chapter 1.4 and complete all steps and then come back. We thought, okay, not bad. We go to chapter 1.4. The first sentence there is, please complete all steps at chapter 1.1 and please go back. This is the reality of data and engineering, which is all interconnected. Yeah, it's we talk now a lot with many of our clients and partners about what are technical limitations at the moment of understanding the requirements, because all our products are based on these requirements. As you know, like for example, a plane have 100,000 of requirements, and like an average simplified, like high level requirements, is as having a novel book, where each word in this book is a separate requirement. And your task is to bring all these words in this whole book seamlessly together for a functional plane. So this is even not possible to process for a human, this complexity. And the question is, can LLM parse that?
Very good. So give us 1 or 2 examples of a positive, good, having worked well, Gen AI in engineering that you've been involved with the last, whatever, year.
So we have, as I mentioned, this cases which we map for ourselves along the V model. And I would say some areas where I'm particularly super excited about are topics like test generation, but functional manual test generation. So of course, the ambition is to generate automatic tasks, also like in code development. We can argue like to which manner this is possible, but one of a simple case, if you have a new interface, there's so many people, we have to write very, I would say, primitive tests, which to provide this coverage, like press a button, like press it 2 times, then click on the list to the next page, see if it loads. And this is super repetitive. And the problem is that people who are responsible for this process cannot focus on the actual value of work, of some specific cases. It's for automotive testing, for example. If you're testing HMI, there are so many tests you have to describe and test. And this is one of the areas we are particularly super excited about, because then if you start on one particular area which works, like generation of these tests, you can go to the left and to the right side. You can try, for example, to automate the testing itself. So we have examples where we can actually use a combination of visual models and reinforced learning to split the screen in different parts, and we can test accessibility, or we can test also if the screens are loading. There are many areas which you can reuse and go further across the whole V model. My only single call, I would say, would be to the audience is there are super many exciting areas, and you will hear from use cases across the world that everything is possible. But the challenge is really how to start in your company with something which later will scale. So what I see at the moment, we have hundreds of use cases. Most of our clients have hundreds of them. But where the really challenge is to get a value out of it, because everything is stuck on the POC phase, especially like in many large industrial clients. And what I see works well for us, or also for our clients, is to start with one proven case, like with test generation in automotive, in our case, and then to grow to the left and to the right based on this foundation.
Very good. We need to come to a close, Vlad. I understand, well, sure, you meet with customers, you do workshops with them. So assuming you have shared many of the things that we have just discussed, can you share with us, not going into the details of who they were, but just like, what is the type of feedback you will get today on this very topic of Gen AI and engineering? What do the engineers say? What are the challenges? It's almost like what I said at the very beginning, 30 years back when I did computer-aided design, is that what is the challenge? How do they feel it's going to fit into their strategy? What do they feel are the risks, the concerns? Can you share some of those with us?
Yeah, I think we see now also in engineering the same split of these 2 groups, as we discussed before in software development. Again, of people who think these LLMs as being stochastical parrots, or people who really, I would say, I don't want to say a believer, so we're not some kind of a religious sect of transformers here, but who really, I would say, see the potential of it and understand that there are some limitations. And what I see at 80% of cases, that people try to brute force LLMs for tasks which are not applicable for this architecture. So without understanding of their current limitation, like context size, reliability, the topic that many of the cases you have to perform have connection to other data sources, they just try to use Gemini or ChatGPT for a directly very complex use case, and they are frustrated because they say like technology is not far enough. And then I see another big group of clients, and it's the same for us as well, which are kind of more robust, and they prioritize these use cases and start, okay, let's have a map of a feasibility and the value out of it. And they focus on 1, 2, 3 very simple cases. And you can really see how if you have a first case which works, like also engineers who are super precise, and especially in Germany, are kind of a pragmatic colleagues. So same for me. They really get this excitement because they see that AI is not some of a evil tool which would substitute you as an expert. It's actually an amazing interface and excitement new tool in your toolbox, which can help you to automate the, I would say, ugly hours of your work. Yeah, like your routines, your repetitive tasks, which nobody wants to care about. And in this kind of a club, you see a lot of excitement.
Final question, 1 minute answer max. What is your experience, your own, and I assume as part of a large global organization, when we look at the maturity levels of the large language models, maybe specifically engineering or not, can you give us a view on the different type of market segments that are more ahead of others? Maybe you can also share what parts of the world are more ahead than others?
Yeah. So that was 2 questions. First one, or even 3, and I will just keep it in 1 minute. I think in all areas, it's like kind of a matrix. Yeah, there's strengths and weaknesses, and the media is very selective on translating them. So we see always these hype waves of new models, but there is 1,000 models coming to the market each month. So I cannot advise really to be over focused on new models. This is a run which has no end. Then there's another area of industries. And also there, we see some topics like automotive is very good now in advancement in physical AI and automation. But there's actually strengths in each industry. Like life sciences at the moment is super leading in topic of edge or how responsible AI on how to be compliant. So what I really enjoy about the situation now, especially in our position, that we can really learn best from each industry and try to bring it together and maybe even translate from one discipline or industry to another one. And to your third question about the different markets, also there, to be honest, so I just coming back from China, where we had several workshops with our colleagues on topic of AI and engineering, and I came back with very good feeling, I have to admit, because I would say also our media are talking really, not in the best light about our current setup. Sure, we have to give a bit more velocity and speed on digitalization, but I believe really that we are still very good at our pace, and we have a lot of potential. Just giving one perspective, what was not clear to me, 2 major changes which we had in AI field with democratization challenges were ChatGPT, which explained or showed the public how powerful transformers are, and then was the question how we can bring it to enterprise. And then we have Microsoft Copilot, which gave a compliant way to integrate this technology to enterprise. And both of these 2 major happenings were not happened in China. So it was not clear to me, but sure, we're talking a lot about the DeepSeek and how China is advanced. So talking real to clients and to colleagues in China, I would say they have definitely their strengths. But if we talk about the integration of LLMs and AI into industrial processes, I think we are still on a very good trajectory. There's a lot to be done, and I think a lot of improvements we can do, but I think we can really be also proud about our advancement at the moment.
That was a great closure, almost within 1 minute, Vlad.
I tried.
as I'm sure listeners will agree with me, we could have this continued for at least an hour. We'll do that in a year or two, look back at where we're standing then. Thank you very, very much for your perspective
Sure.
on the use of AI, of Gen AI specifically in engineering. Have a great day and talk to you soon again.
See you. Bye. Thank you, Peter.
Thanks. Bye-bye.